Woodworking CNC routers are a great tool, but they create a lot of dust. This is not only a mess in your shop, but it affects as well your health. You can battle this with a dust shoe, and they usually work well with flat material, but they have their problems with more complex shapes. Also, ATC and force axis compatibility with a bulky dust shoe is a challenge. That's why I try to go in a different direction. In this video, I will show you how I have integrated the components of an industrial air cleaner in the top of my enclosure. So if you're interested in a teardown and want to see what's inside of such a cleaner, see some woodworking, including the first CNC mishaps, and how to integrate the components in the CNC so they are automatically controlled by the spindle, watch till the end. Hello and welcome to my channel. The build of my new woodworking router is in many aspects a tight fit in order to maximize the ratio between the work area and the available space. One of the limiting factors was the enclosure, which sits in the corner of the shop. On the left side, it is limited in size by a window and in the front by the depth of the workbench. And with the work area of 1250 by 700 millimeter, I really maxed out the space within the enclosure. As you can see, there's not a lot of space for bulky add-ons like a dust shoe. When I move the Z-axis to the far left, there are only a few millimeters space between the Z-axis and the enclosure. In addition, on this side of the spindle is the tool release button, so it is nearly impossible to route a hose along that side. And when we move over to the other end, you see that there is not a lot of room either. When I move the gantry to the front position, it is even worse, with again only a few millimeters left between the spindle and the side window. This makes it really difficult to add a dust shoe, especially one with a bigger 80 millimeter hose. Because I find real-time chip evacuation with a regular shop vac and a 36 millimeter hose rather difficult, because such a combo usually cannot cope with the amount of chips and gets clogged really fast. That's why I mill wood without chip extraction directly at the spindle and only remove the chips after the job with the shop vac. This is of course not ideal, and it is important to protect the rails and ball screws as best as possible from chips piling up directly on them. But my fixture plate, which by the way is not in place yet, covers most of the bed axis, and in addition I have extra seals on the carriers on all axes. But in this case it is important to evacuate at least the very fine dust in the air, so only real chips remain. On my old router, I used to have an industrial air filter right on top of the enclosure, and that worked in fact so well that I had planned from the beginning to use it for this machine as well. The only problem is that the new router is somewhat taller and I do not have the space to put the cleaner on top. We have some drywall under the ceiling which covers piping, and this leaves not enough room for the box. But I figured it might be enough room for the actual filtration components, just in a different arrangement, so I gave it a shot. This air filter is actually quite effective in smaller rooms. It comes with 3 different speeds and has an airflow of 400 cubic feet or 11.2 cubic meters per minute in the highest mode. My enclosure has roughly a volume of 2.5 cubic meters, so it should exchange the air in theory every 13 seconds. I didn't really know what to expect in the teardown and how difficult it would be to integrate the components in a different arrangement, but it turned out there's literally just a handful of parts to worry about. At the very front is a filter, which can be easily removed and as well cleaned. Once it is beyond cleaning, this could be easily replaced since it is a service part. It is supposed to filter parts bigger than 5 microns. I used to do this twice per year on the old machine. After this first filter, which already takes most of the dust, comes a fine particle filter with a 1 micron filtration. This can be removed and cleaned as well. At the rear end of the housing is a plate with the air blower and the control unit. That's it. Shouldn't be too complicated. The air blower is a unit out of the actual fan, the motor, and the outlet. This should be easy to mount somewhere else. But I have never been a big fan of the control unit, however. It is a mixture of push buttons and a redundant remote control. This thing is designed to hang permanently running from a ceiling, and in this case the remote makes perfectly sense, but my use case is a little bit different. It always starts in a low stage and you need to push a button several times to move it into high stage and again a different one to shut it down. But ideally I want to have it on when the spindle runs and off when the spindle stops. So my first task was to see how the control actually works and if I could somehow trigger it directly from the CNC controller rather than with the push buttons. It took me a while to figure out how to disassemble the cover, and after I finally got through to the controller PCB, my hopes to trigger that directly from the CNC died very quickly. After all, I'm not much of an electronics guy. But it looked like the phase line is permanently connected to the motor, and that for each speed, neutral is switched to the motor by a different relay. And yes, the small handwritten designations of the cables are actually from me, added before I filmed this again. I wanted to be sure, so I connected the board to 230 volt and checked extremely carefully if my assumption was correct. And I mean extremely carefully, because working with live 230 volt is quite dangerous and touching of a live phase is no fun. So folks, don't try this at home. Okay. That was low power. That's medium power. And here we have high power. Okay, so confirmed. And with this working principle of the motor established, I decided to completely ditch the original electronics and rather run the motor always in high power, but triggered by an Eltako relay with a holding delay function. So it starts together with the spindle, but still runs a certain period of time after the spindle stops again. After the overall feasibility of my idea was confirmed, I started to build the new housing, which fits exactly into the open space between the top of my enclosure, the drywall cover, and the ceiling. I built this with 25mm MDF and 12mm birch ply. Cutting longer boards in my tiny 13 square meter woodworking shop is always a bit difficult because I have to make room by moving things around. And the way I stand in front of the table saw is also far from ideal, but it is what it is. In order to screw the MDF to the drywall, I used special dowels, and this worked really well. And then it was time to use my new woodworking router for the first time for what it is supposed to be, cutting wood. Since I haven't made the fixture plate with the vacuum holding function yet, I had to improvise my work holding though. First, I taped the temporary spoil board out of 3mm HDF to the frame using double-sided carpet tape. Then I fixed the workpiece to the spoil board using the tape and glue method. The green tape is 3M2060, and this is by far the best tape for this kind of application. It sticks like crazy, and yet it is easy to peel off again. I even use this for holding aluminum parts in special occasions because it can withstand the MQL coolant for a while. I have linked it in the description below together with a few other things I used to build this air filter box. The glue is a regular CA glue with medium viscosity, but you can basically take whatever you have on hand. I haven't noticed any differences yet. The plyboard is aligned to the x-axis using two M8 bolt heads in the frame where later the real fixture plate is mounted. For these parts, this is precise enough. I used the touch probe to measure X and Y0, but since the tool setter and the probe are not finally configured yet, I had to measure the workpiece Z0 with the good old paper method. And hey, what shall I say? Already with the second part on the machine, I managed to have my very first ever. This happens when you use a CNC before everything is finally configured and you use workarounds to your normal procedures. But look for yourself. It totally makes sense to have the spindle running when you want to mill, doesn't it? What happened here is clearly carelessness on my part. My post-processor adds after each tool change a command for the tool length measurement, which in this case I had to disable since the tool setter isn't set up yet. This is done by simply putting the command in brackets. But for whatever reason why, I must have been distracted and I have changed the G-code twice, putting accidentally the M3 command in brackets as well, with the obvious end mill death as a result. Tough luck, and with the next one everything was okay again, but I learned a valuable lesson. When you work outside of your normal procedures, pay extra attention to what you do. And hit the E-stop immediately rather than watching the approaching disaster in awe. Once all the wooden parts were done, I could screw and glue everything in place, and after that I started to assemble the new control. And this is really not complicated at all. There is a fuse, a Siemens Contactor, an Eltako Relay with delay function, and a few terminals for easier wiring, all on a DIN rail which can be easily screwed into the box. The contactor connects the 230 volt power to the motor and is triggered when the CNC controller is switched on. The Eltako Relay switches on and off with the spindle. I have a custom M3 and M5 command for this, which triggers one of the outputs of the CNC controller, which in turn triggers the Eltako. The delay function is set with two small rotary switches, one for the time and one for the multiplier. I set mine to 5 seconds with a multiplier of 9, which gives me a total shut-off delay of 45 seconds after the spindle has stopped. In case you want to know more about this relay, I have linked it in the description below as well. The entire unit is wired outside of the box, so that the only cables missing are the 230 volt supply, the two cables from the controller, and the motor wires, which can be easily connected to the terminals once it is in its final place in the box. The last thing to do was to mount the blower unit to the front cover of the new box and to extend the motor wires. I prefer to do this with proper Vago splicing connectors rather than with the originally used cable shoes because of a better insulation. And then it was time for the first test. The blower automatically switches on when the spindle starts. If I want to run the spindle without the air filtration, however, I can disconnect it from 230 volt with the contactor by simply pressing a switch on my control panel. And when the spindle stops, the motor still keeps running for the selected delay time to clean every dust which still might be in the cabin. I'm quite happy how this turned out. Nevertheless, I still wrap my head around how I could possibly add an additional dust shoe to the spindle without compromising too much work area. In the next video, I will make the fixture plate with the integrated vacuum function and finally finish this build. If you like this video, give it a thumbs up, subscribe to the channel and hit the notification bell. Stay tuned and see you next.